Okay, so hello to everybody. My name is George Kaliampos. I hold a bachelor degree in physics and a PhD in science education. And today I will present you the study, the transformation of children's mental representations of 5 to 6 years old for coagulation, precursor models through a storytelling approach. We did this study with our team, which is aparted from Michalis Ioannou, a PhD student, the assistant professor Panagiotis Pantidos, and the full professor Konstantinos Ravanis. First of all, I would like to express my many thanks to the committee that give me the opportunity to participate in this conference, and of course express my warm greetings and feelings to all the Ukrainian people. So I am from Greece. Our team is from Greece. You can see here, Greece is located in the south part of Europe. And it has almost 10 million population. Our capital is Athens, and half of the population live in the capital. We are almost 1,400 kilometers from Kiev, and I live and work in Patras, which is the third biggest city in Greece. It is 220 kilometers from Athens, with a population around 170,000 citizens. We are a quite big port regarding Greece, and we have in Patras the University of Patras, where I live and work. So here you can see some photos from my city, the port, the city center, and the university. So now let's start with the study. The last decades, constructivism has dominated science education. And at the core of this theory lies the alternative ideas. Alternative ideas hold their origins from both the natural world and the socio-cultural world. An example of how alternative ideas come from the natural world is if the fact that a tile feels colder than a wooden table, for example. Or another example that shows how alternative ideas come from the sociocultural world is the fact that many children quite often hear expressions like close the door so the cold doesn't get in. Within early childhood science education, the precursor models seems to play a key role in the last years. Precursor models are actually cognitive entities which interpose themselves between the original children's representation and the scientific models used in education, and actually they allow pupils to put forth thought processes that surmount the obstacles of their thinking, and they are compatible with the scientific ones. So, what we did in our study was that we did an experimental investigation, qualitative in nature, and it was aparted, the study, from a pre-test, a teaching intervention, and a post-test. We carried out individual semi-structured interviews, and the sample of our study was 99 children aged 5 to 6 years old. The aim of the study was to answer the following research question: to what extent can a storytelling intervention help children 5 to 6 years old construct a precursor model regarding coagulation? So here you can see the three tasks that parted the pre-test and the post-test. In the first task, melted butter in the cold air, the children were shown a piece of butter that is melted on the flame of a camping gas, and were asked what would happen if in the melted butter if we let it outside in the cold night. Regarding the second task, melted butter in the fridge. Again, the children were shown a piece of butter melted on the flame of the cabin gas, but now they were asked what would happen in the melted butter if we place it in the fridge. And in the third task, melted chocolate in the cold air. A piece of chocolate was melted on the flame of a cabin gas, and the children were asked what would happen in the melted chocolate if we let it outside in the cold night. The teaching intervention was based on a storytelling approach, and the story that was told to the children took place in a house located near a lake during a very cold winter. And actually, the parents of a disobedient child had forbidden him to take the boat in the cold afternoon and go for a ride on the lake, but the child disobeyed them and secretly took the boat. The water froze in the lake, so the child stuck there. The parents searched for him, and when they found him, they melted the ice with fire and unstuck the boat. And when they asked him why he did this, the child in the story answered that he did not believe that the air in the lake around the boat would be as cold as the refrigerator to cause the water to freeze. So the narrative was dialogic and interactive, and the emphasis was given on the relation between the cold air and the refrigerator. The results were classified into three distinct categories: sufficient responses, which were those that were compatible with school scientific knowledge; the intermediate responses that were characterized by some kind of shortcomings or contradictions; and the insufficient responses that had nothing to do with school scientific knowledge. Here you can see in the table the results and some indicative results. I will just tell a few of them. In the task one, for example, a sufficient response was that the butter will become hard again as it was before we melted it in the fire, as it will cool down during the cold night. In the second task, an indicative insufficient response was that in the fridge it will stay the same. And regarding the task 3, an intermediate response was that the chocolate will freeze during the night. Your throat will get cold when you drink it in the morning. So, what we found was that children 5 to 6 years old face great difficulties in conceptualizing coagulation, but the storytelling approach has had a very positive impact on children conceptualizing coagulation. And after the intervention, the vast majority of them were able to associate cooling with coagulation. Quite interestingly, in task 2, almost 76% identified the refrigerator as an appliance that causes melted butter to coagulate. So the function of a refrigerator begins to act not only as a familiar cooling, preserving storage space for food, but also as a system that is involved in thermal exchanges. So the consistency of children's reasoning found across all tasks in the post-test supports the view that early childhood children are capable of constructing a precursor model regarding liquid coagulation. And in the heart of this model lies the concept that the wider environment acts as an appliance that has analogies with the refrigerator. It should be noted here that this precursor model does not include the mechanism of interaction between hot and cold systems, for example, the issue of thermal equilibrium. And this is why we called it precursor model, because it is between students' ideas and the scientific model. Some study limitations is that it is, of course, a small sample, and the fact that the approach was confined only into the usage of familiar materials. Further research could be done regarding the studying of the stability of the precursor model through quantitative approach in a much more large sample, and through the comparison of children's reasoning between familiar and non-familiar materials. Thank you very much. And here is some indicative reference of the study. Thank you again.